Before we move on from this plane problem, I did mention this a couple times kind of in passing, but there are some aspects to this, this graph and this equation that are sort of important. One is the slope of the line, the negative 1200. That is the rate at which the plane is descending. And you can see that slope in the table as we're going, the change in y versus change in x over here, negative 1200 for every minute we move forward. Also the two intercepts, the x-intercept down here, the place where the line crosses the x-axis, is tells us the time at which the plane reaches an altitude of 0, because altitude is 0 at this point, and the time is about 13 1/3 minutes, but an altitude of 0. And over here is the time is 0 and the altitude is 1600 or 16,000. Sorry. Now, time being 0 in a math problem like this means that that's our starting time. That's the time that we're measuring from. Every time in our problem is measured from that initial starting time. And at that time, the plane was at 16,000 feet. So y-intercept tells us where the plane is at our initial or starting time, and that's kind of arbitrary. We just picked that. Okay? And then the x-intercept shows us the time. Of course, everything's a time-altitude pair. So here is time when altitude is 0. We've gone down. We've reached 0 on the y-axis. That's an altitude of 0, and that's where the time is when that altitude is 0. That's when the plane lands. And the slope, which we calculated as negative 1200, is the rate at which the plane is descending. And we've talked about slope as rate several times. So that is, kind of in a nutshell, what the intercepts and the slope represent in this plane problem.